Hello, everybody, and welcome back to my channel. As the heat wave grips the country, I hope that you are all staying fit and hydrated. With that, let me kind of introduce you to this shoot, and this is part one of a two-series shoot. And here I'm going to talk about how digital technologies can be used to improve the ESG performance of buildings, plants, and factories, and so on and so forth. Now, ESG has moved from a peripheral conversation to a central conversation in boardrooms, and therefore it is important to understand how digital technologies can be leveraged to reduce energy consumption and distribution of energy. So in this video, I'm going to specifically focus on reduction of energy consumption or optimizing the energy spend. Now, what we need to also understand that energy spend or understanding about energy is to be able to collect data as from different sources of energy as they get consumed, analyze the data, and create autonomous systems which can give insights back to either an individual or group of individual or a computer system to be able to make corrections on the way the spend is used and thereby reducing waste over time. With that, now let me take you to the presentation, and here goes. Part one of a two-series presentation around reducing energy consumption. Here we're going to talk about the context of energy consumption, digital technologies used, and going to talk about three or four elements, three or four technologies which enable this process over time. And with that, let's get started. In the internet, as per the data of the International Energy Agency, that implementation of energy efficient technologies and smart energy management system could reduce energy related CO2 emissions up to 70% by 2050. And therefore, the other point was deployment of smart energy grids could reduce carbon emissions by 9% by 2030 and 30% by 2050. And we're going to talk about smart grids in the subsequent video, but here we're going to focus on buildings, which is residential, commercial, and public buildings, and how that energy consumption gets impacted by use of digital technologies, which is including how energy is consumed in heating, cooling, ventilation, lighting, and so on and so forth, and how we can optimize this 36% final energy consumption and also spend time on the residential sector, which accounts for 29% of final energy consumption. This obviously includes the energy that we use at our homes, space, water, heating, cooking, and so on and so forth. And in that context, we're going to talk about 4 or 5 technologies, actually four, where building energy management system is what we're going to what gets applied in the larger buildings, the commercial or the office spaces or public buildings. And we're going to start with that, talk about the technology and the companies that are using the technology. Smart thermostats, energy monitoring apps, and smart lighting are what are part of what is called the smart home. And as we optimize our homes and digitize our homes, how does these different components play out in optimizing our energy expenditure and thereby reducing wastage and enabling the ESG agenda? With that, let's get started with the building energy management system. Now, the start point of a building energy management system is the application of digital technologies to allow for monitoring, control, and optimization of energy used in buildings. There are a network of sensors, controllers, and softwares that work to collect data on energy use and make adjustments to optimize energy consumption. The first thing is obviously to have a sensor network, which includes a network of sensors that collect data on energy use through the building, which could be temperature sensors and which parts of the building get heated or where there are excess energy use, occupancy sensors, which basically says which part of the building are occupied, to what extent of occupation, or in retail spaces, what is the amount of footfall, and therefore what lighting should come in and the use of energy, and then obviously light sensors and so on and so forth. Now, once this sensor network is set up, they actually emit data, and the data is collected and then fed into a central software that processes the data and provides insight into energy usage pattern and areas of waste, which says that, if the footfall comes down or occupancy reduces, should the energy consumption come down to that same gradient or to certain other parameters, which is where the energy wastage is reduced. After that, obviously, there is a control system which allows for remote controlling of energy consuming systems like lighting, heating, cooling. And the control systems may be operated manually by building occupants, where you can actually switch on and switch out depending upon the feed that you get in, or automatically by a building energy management software. But the most important thing is the optimization, where the BMS uses algorithms to optimize energy consumption based on real time energy usage patterns and occupancies. This could include adjusting lighting levels, adjusting temperature settings, and turning off energy consuming gadgets when not in use. Now, this is where the actual value is. And finally, the reporting of it, which says that how much energy was consumed, patterns, and so on and so forth. The important aspect of reporting is that energy leakages happen because of certain practices and behaviors. Now, we could educate people on how these behavior patterns can be modified, which is how do you switch off lights and so on and so forth, which is in the analog world. But behavior change takes a lot of time, and therefore these optimization algorithms recognize certain behaviors where energy gets wasted and these algorithms are enabled to take corrective action by turning off the temperature settings, by adjusting the temperature settings, or turning off energy consuming systems when they are not needed. Now, if you look at these are examples of companies who are big in energy, building energy management software. And obviously, we are talking about 36% of final 36 or 38% of final energy spend. Therefore, it's a fairly big play. Now, this was in terms of the commercial buildings or the big buildings. And now we're going to talk about devices which actually enable the smart home. As the world is getting smarter and devices are getting smart and intelligent, inside our homes, energy management devices are also come to weight. The global thermostat market size is worth about 4.2 billion in 2021. But what is more surprising is the projected to reach 40 billion by 2030 at a CAGR of 28.2%, which is going to be big business. The use of digital technology to optimize heating and cooling is based on user preferences and occupancy patterns, thereby leading to significant energy savings by avoiding unnecessary heating or cooling when no one is at home. Now, what the way it works, like we take an example of Google Nest, is there are ML algorithms which learn by the user's schedule, which means it actually tracks the way you move around in the day, and therefore it adjusts heating and cooling settings automatically and thereby reducing it. So there is no manual control of the heating and cooling system. Just by putting in a Google Next, it automatically figures out the time and the extent of usage, the footfalls, and therefore adjusts the temperature settings and the lighting settings to optimize the energy usage, which is true. This is the same technology used by Ecobee, Tado, or Sensai. However, Honeywell is another big company, and it's into the building energy management software, like we saw in the bit. They offer several smart thermostat models and features like geofencing, which adjusts temperature settings based on the location of the user's smartphone. And thereby using this geofencing technology, it further optimizes energy and is linked to the physical movement of the user. Well, pretty cool, isn't it? Moving on, let us look at energy monitoring apps. Now, energy monitoring apps are digital tools that enable users to monitor and analyze the energy consumption. Obviously, there is a data collection process where you collect data on energy consumption from various more sources. Obviously, for energy monitoring apps to happen, you need to have smart meters, smart plugs, and other sensors. It is typically transmitted to the app through a wireless connection or a Bluetooth or so on and so forth. And then this data gets analyzed by using algorithms and analytical tools to provide for insights on energy consumption pattern. And then there is a report that comes out, and there are recommendations of how to use energy more effectively. The most important thing, this energy monitoring apps integrate with smart home devices such as smart thermostats, smart plugs and plays, and lighting systems. Thereby, the data feed that comes out, which are not covered by smart thermostats, are integrated by energy monitoring apps, which enable the thermostats to function even better. Finally, these are some examples of energy monitoring apps, and I'll let you see them with the Energy Hub. These are apps which are in vogue right now. But I mean, let's move on. Now, when we talk about smart lighting, right? Smart lighting works by using digital technology to control and automate lighting systems in homes and buildings. And typically, the components are collected lighting devices, which are basically again smart switched, which are kind of sensorized, where there are light dimmers, can be controlled and programmed by mobile app. Now, then there is a network protocol, which is Wi-Fi, Bluetooth, allows the controls to move in, the data to be collected. Then comes the automation, which adjusts, which can turn on and off based on the environment. And there is a voice control, activation, and energy monitoring. Now, these are, I mean, Signify, Philips, GE are the big players in this business. Now, coming back, so basically, what is the energy management system, be it at a home level or at an industrial level? How do they operate? Simply put, they actually have sensorization. Different kinds of sensors are put into the devices, which make the devices smart and connected. This device goes to the ubiquitous cloud, and the data gets programmed. The data gets kind of massaged, and a particular pattern is recognized, and an algorithm then gives an insight to say that how these devices should be managed or to reduce and or optimize the energy consumption. Now here we are talking about 29 to 36% in terms of industrial buildings and 29% in terms of home. Now by doing so and understanding user preferences, our ability to reduce energy consumption is going to be significant. And here we are talking about 66% of the world energy usage. Obviously, needless to say that this is going to be a very big deal. And watch out for the industry, watch out for thermostats as an industry and smart homes as an industry. However, what we also need to know that the impact is dependent. However, the reduction in CO2 emission depends on various factors, and it is important to call them out, which is the level of deployment of these technologies, prevalent energy mix in these countries, and the efficiency of technology used. However, when we talk about 36% in terms of industrial buildings, in terms of final energy consumption, and 29% in home, it is likely going to be higher in developed countries where the use of electricity and the consumption of electricity is kind of the gadgets are far more sophisticated in the developed world or the developing world. So that is where the market is going to play out first, and subsequently as economies emerge, it is going to come to these parts of the world as well. Now the point that I'm trying to make is, with these kind of technologies, has an impact on our sustainability agenda, and it is important for all of us to participate in the process. In the next video, I'm going to talk about smart grids and how smart grids and smart meters actually help the distribution of electricity and energy to be more optimized. So stay put till I kind of present to you the next video. Hope you had a hope you enjoyed watching this. Do share, like, or the kind of promote this video as you deem fit. Till we meet again, thank you for your time. Bye bye.